Welcome to another lecture of our prologue playlist. Today we will going to learn how to remove duplicate elements from a list. Okay, so if a element is present more than once in a list, then we will remove it. So for that we will take help from recursion, and first we will write the base condition, that is if the list is empty, then we will going to return an empty list. But if the list is not empty, then we are obviously going to traverse the list. And how do we do that? We just divide it into two parts, that is h and t, head and tail, and we take the head element and do operations with that, and then we recursively call the function again with the rest of the list, that is t. So here we are going to do the same, and the r is the resultant list which we are getting after removing the duplicate elements. So now let's check if h, that is our head element, is a member of the rest of the list. So if h is a member of the rest of the list, that means h is already present inside the tail part, so we can remove the h. Okay, we can ignore h, or we can just delete h, whatever you can say. Okay, and after that we are going to again call the recursively the function for the rest of the list. But if h is not a member of the list, then what we do, we just append h, or we must not say append, actually we are just adding h with the rest of the list. Okay, with the resultant list. So what we are doing, if h is a member of the rest of the list, we are ignoring h, or we are doing nothing with it. But if h is not a part of the rest of the list, that means if h is a unique element, then we are adding h to the resultant list. Okay, and for each case we are recursively calling the remdef function, that is to remove duplicate. And also when it reaches the base condition, that is when all the elements are traversed from the list, then it satisfies it, and it returns the null list, okay, or the empty list. So that's how we do it. So now let's run it and see. See, here we have a duplicate list, that is fully duplicate elements, and we have run it and get a list without any duplicate element. And we are again doing the same thing for another list, and to show you the result yourself. So now we are adding some more duplicate elements here, and we are going to run it and get a list which has no duplicate elements. So let's see. Now let's move on to our next program. Here we are going to take the sum positive numbers of the list and can find their sum. Okay, so this input list will contain both positive and negative numbers, but we are going to check if the number is positive or not, and then we are going to add them. Okay, so for that we are going to take help from recursion, and we are having a base condition, that is if the list is empty, then its sum will be 0. And if the list is not empty, okay, so for we are dividing in 8 in h and 2, and if h greater than 0, that means if h is a positive number, then we are recursively calling the function again, and with that we are adding h to our sum. Okay, we are adding h to our s. Okay, so s1 here is the sum of the rest of the list's positive numbers, and s will become what? S will become s1 plus h. But if it is not a positive number, then we are just ignoring it, and we are just recursively calling it, but we are not adding it. Okay, for the third rule, we are not adding it, we are just ignoring it and calling it again. So that's how we are traversing the list and checking if the number, that is the head part, is positive or not, then we are adding it. So let's run it and see. So see, here we have a list with both positive and negative numbers, and the sum is correctly giving as 10. And also we are having another list here, and we are also checking it for now. So see, we are having both correct results, only the sum of the positive numbers are getting counted here. So that's it for today. Do subscribe and like our channel.